Solving systems of equations by substitution, part 2. In these examples, we will have two equations that are already in slope-intercept form. The first equation in slope-intercept form, the second equation in slope-intercept form. In this type of scenario, we have y equals 5x plus 1 and y equals negative 8x plus 14. When you have solving a system of equations where both equations are in slope-intercept form, what you want to do is set the equations equal to one another. Once you set the equations equal to one another, then you can start to solve the equations by getting the variables on one side. So that gives me 13x plus 1 equals 14 minus 1 minus 1. So 13x equals 13. Divide both sides by 13. X equals 1. Now that I know that x equals 1, I can plug 1 in for x in this equation and solve for y, or I can plug 1 in for this x value and solve for y. I'm going to do it for the top one. So y equals 5 times 1 plus 5. So that equals 5 plus 1. So y equals 6. So our solution is 1 comma 6. Now, I'm going to go ahead and show you that if we were to use the bottom equation and substituted the 1 in there, that we would come out with the same answer. So negative 8 plus 14. So negative 8 plus 14 is 6. So you can see that no matter if we use the top equation or if we use the bottom equation when we're substituting the x value back in to find the y, we will get the same solution. Okay, and remember that when we solve for an x and y, that means if we were to graph these two, the point of intersection would be at 1 comma 6. Now let's look at another example. In this example, both equations are in slope-intercept form. When you have both equations in slope-intercept form, you will set them equal to one another. In doing so, you'll arrange an equation like this. We will start to solve the equation, so we'll move 5x to the other side. Gives me 5 equals 7x minus 5x is 2x. Bring down the 7. Move our 7 to the other side. We get negative 2 equals 2x. Divide both sides by 2. So we get x equal to negative 1. Now that we know what x equals, we can either substitute it in for this value of x and evaluate for y, or the bottom equation. Either one is acceptable. So I'm going to take it and substitute negative 1, which is the value of x, into the first equation. 5 times negative 1 is negative 5 plus 5. So y equals 0. So our solution is negative 1, 0. That means if we were to graph these two lines, we would expect it to intersect at negative 1, 0. Meaning that negative 1, 0 is a solution, is a point on each one of these lines. This concludes part 2 of solving system of equations by substitution.